And she's a PhD student in software engineering and cybersecurity lab in the Gianforte School of Computing at Montana State University. Her PhD research focuses on how to create software to meet user expectations and enhance perception. Her previous research is very interesting. It was on modeling biochemical processes in soil. And she received her master's degree at the University of Utah in geography, studying soil microbes. So quite a transition into her new area of expertise. And she's going to lead us on a very interesting digital forensics hands-on learning.
Cool.
All right,
Thank you, Brittany. Thank you for that introduction. So just to start off, yes, I am a physical scientist. I started out in chemistry. If you guys are interested in hearing about the progression from chemistry to software engineering, happy to share that anytime. Just feel free to ask. So I am part of the software engineering cybersecurity lab at Montana State University. Just because my research focuses on software engineering and I'm associated with the lab, I do get to hear all sorts of things about cybersecurity. So I've been starting to dabble in cybersecurity related aspects. Digital forensics is something that has piqued my interest, and so I'm excited to share this information with you. So this is a hands-on, so I will be doing a demo, but before I can do the demo, when you guys get your hands dirty, I do need to give you some sort of context, so that way you actually know what you're doing. Sorry, just advance here. Okay. So the first portion I'm going to only talk for about 45 to 50 minutes, and then that will be your turn to start playing with the actual tools. So I'm just going to cover what digital forensics is. I'm going to talk about what makes up digital evidence, how we can collect that evidence. During that portion of the lecture, I am going to ask for some volunteers to just shout out some answers. If you do shout an answer, I do have candy. So you guys can. Okay. And then I'm going to cover the analysis tools. I'll be giving you an example of the analysis tools. And then I do have slides for incident response and incident management. We're probably not going to have time to cover that. So if you're interested in that, that information is there for you. You can take a look at it at any time. The slides are going to be available here in a little bit. They're not available just yet, but they will be. And then the second portion of the session is going to be a capture the flag. So you're going to be given some tasks to go through using the volatility 3 framework. You're going to be looking at memory forensics, and you're just going to be solving little aspects of searching files. Okay, so what is digital forensics? So before we can look at digital forensics, we just need to know what that base term is. What is forensics? And so Wikipedia defines this as the application of science principles and methods to support any sort of legal decision-making in any matter of criminal or civil law. Essentially, what we're doing is we're collecting any evidence to support or review our criminal cases. So many of you may have seen this show or heard of it, CSI. I think there's a CSI Miami, maybe CSI LA, not really sure. A lot of times their scientists will go out and collect biological evidence. Since we're looking at digital devices, our criminal scene investigation method is going to be that digital forensics. So digital forensics is just collecting the digital evidence. We're going to analyze it. We're going to interpret it. This can be done in real time, so while the attack is actually occurring, and it can also be done after the attack has occurred. What we're wanting to do is answer those two what, when, where, and why questions. We want to know who actually attacked us. Why did they attack us? We want to understand the root cause, and so that way we can find out how do they infiltrate our security protections, and that way we can prevent it from happening again in the future. So there's 4 main types of digital forensics. There's going to be our disk and memory forensics. This is going to be what's actually residing on our digital devices. And then we have our network forensics, which is going to be looking at any sort of traffic between computers. What's that information that's being transferred from one computer or digital device to another? And then the last one here, live, it's going to be integrating the previous 3 memory, disk, and network forensics. This is going to be when we're doing the on real-time investigation for any sort of digital forensics. Okay, so memory forensics, we're going to be looking at the running system of the memory. That's going to be what's stored in RAM. And so this is going to be that information that is temporary. So who can give me some information or tell me what makes up the files or the processes in RAM? What information is actually located there? It's okay to raise your hand, speak up.
Is like memory actively being used?
Yeah, yeah. What's another example? I can't throw, but I'll try this. Oop, that's kind of close. Anybody else have any examples?
What was the first answer?
It was packets. No takers? All right. So we can see information pertaining to our programs and files, those packets, any sort of keyboard inputs, that information. We can see any sort of decrypted content inside that RAM space. So when we get to disk forensics, this is when we're going to be looking at the actual magnetic or solid state disks. Those are going to be the actual physical devices that are holding information. Could be your hard disk drives in your computer, it could be a USB thumb drive, it could be an SD card. We're typically going to use disk forensics when we can't actually access that running state memory, just because if the computer gets turned off, that information RAM is no longer going to be there. We're also going to use disk forensics to look at any sort of historical activity. And then it's really important when we're looking at the different types of forensics when we go into our file explorer or that file tree, we click on a file and we hit the delete key. We just need to remember that when we hit delete, that file is never actually deleted until its spot in memory is replaced. And so there's always going to be some sort of remnant of that deleted file. So again, very important to remember when you're doing different types of forensics. The last two, network and live forensics. Again, the network forensics is just going to be looking at the traffic between devices. It's going to be looking at the information in those packet captures, the logs, the information that's being transferred back and forth. And then the live forensics is just going to combine all three of those and looking at everything that's happening in real time. Okay, so now that we know what the digital forensics types are, we can actually start looking at that digital evidence and how we can collect that. So the National Institute of Justice does define digital evidence as the information and data of any sort of value to an investigation that can be stored on, received, or transmitted by the electronic device. Essentially, this is anything that's digital that can be used to support or refute our criminal cases. And so we have different types of digital data. The first type is going to be our open computer systems. This is basically going to be any type of computer system that has an operating system that gives us full control of that system, or pretty much a wide range of controls for the system. So who can give me an example of an open computer system?
Our laptops.
Yeah. Yeah, exactly. So our laptops and desktops have that pretty powerful operating system. We can do a lot of things. We can program on it. We can change the running state of our computer. The next type of digital data, and this screen here, Sandy, it's going to run it to you. I don't watch the face. Our next type is going to be the embedded computer systems. These are going to be the ones that have a restricted to no operating system. So we're not able to actually control the device by itself, or just have very limited control. So who knows an example of an embedded computer system?
Yeah, like electronic systems, like your car, maybe.
Yeah, exactly. Yeah. Anybody else have any other examples? Yeah.
Would a motherboard be one?
Yeah, mother could be board, definitely be one. Because yeah. Yeah.
Those LED lights and then what's over there?
Yeah. Okay. So yeah, we have controllers in vehicles. We do have smart cards. The mobile device is kind of interesting because it can be fitted under open computer system or an embedded computer system. But because it typically has a limited operating system on it, it's going to be considered more of an embedded computer system. So the last type of digital data are going to be those network systems. So this is again going to be where we're transmitting information from devices on the network. So who can give me an example of a network system?
Like Wi-Fi?
Yeah, Wi-Fi. Yeah.
I associate with like router.
Routers. Yeah. 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 Okay, perfect. Guys are getting me on my exercise. Okay, perfect. So now that we know the types of digital evidence that we can start looking at collecting, we can start looking at the importance of the investigation. We want to understand the actual context of that investigation. Once we understand the context, we can start learning what types of evidence we need to collect, if it's that network that does for that memory evidence. And then this is going to determine what kind of capture tools we're going to be using, what kind of software or hardware are we using to capture that information. When we're looking at evidence collection, it's really important that we're following any processes or procedures that have been established by an organization or federal governments, just because if we violate that, we're putting ourselves at legal risk. We're also running the risk of the data being thrown out by the court. So if we illegally collect data, the judge at a court is just going to say that's not useful. You can't use that. You did not comply with any state or federal regulations. So when we do collect evidence, there are principles that we need to follow. So the first one here is when we collect evidence, we want to make sure that whatever we're doing, we're not changing any of the information that we're actually collecting. This is really important because if we accidentally plug in a device into a computer or any other type of device, and it installs a new piece of software on that device, we've just now changed our digital evidence. The next principle that we need to follow is that we need to be aware of when we're accessing original data. Again, we don't want to change anything. We need to be confident in what we're doing. We need to explain any relevance or implications of what we're actually doing with the system. So if we are plugging a device into another device to extract information, we need to explain, okay, this is why we're doing it. If we screw it up, this is what could happen. The third principle is that we need to create an audit trail or some kind of record. We need to document everything that we're doing. This is extremely important because when you go to a court case, they are going to ask you for your documentation. What methods did you use to analyze the data? What tools did you use? Who's been in contact with the data? This is going to really be important for your investigation. And then the last principle here is that whoever is actually in charge of the investigation has the overall responsibility. Those are the people that are going to make sure that you're following policies and procedures, making sure that you're retaining the integrity of the data that you're collecting. I'm going to stop for a second to get a drink. Your guys' phone here is a little bit different than Montana. Okay, so when we're collecting evidence, there's always some exchange that happens between evidence or any devices that are interacting with each other. There's this principle called Locard's exchange principle, which is looking at the contact between two items, and any of that contact is going to result in some sort of exchange. Essentially, every contact leaves a trace. So anyone entering or leaving a crime scene is going to take something with them or leave something behind. And so this is just a reminder that every interaction can result in some sort of trace. And so, for example, here we have our hacker. The hacker gains unauthorized access into our computers. And so because we have somebody entering our computer systems, they're going to leave behind some sort of data. So who knows what kind of data this hacker can leave behind? Yeah.
Usually IP address.
Yep, IP address. Anybody else? Yeah.
Depending on how they have access, they probably have a backdoor which has its marks, you know, where to look.
Yeah, so it has login information. Okay. Yeah, for sure. Good. Okay, you guys want more? And there are others that a hacker can leave behind. These are just examples. Okay, so when we collect data, we want to make sure, or that evidence, we want to make sure that we're maintaining the integrity and the soundness of the data. Again, we want to make sure that nothing's been modified. We want to make sure that we're documenting everything that we do. When we extract information or that digital evidence, when we're collecting it and creating the captures is what we're going to call it. The software and hardware tools that we use create these hash functions. And this is just going to work as a cryptographic fingerprint. So that way we can compare those hashes from when we originally collected the data to when we're done with the analysis to make sure nothing's been modified. And then we're wanting to show how we preserve the evidence, who's actually touched it. Again, we're just wanting to document everything that we're doing. We can see all those examples here. Lastly, we need to make sure that we're following or just thinking about the legal considerations. Again, anything that we do, if we're failing to follow those policies and procedures, we're putting us at risk of any sort of liable action. All the data can be thrown out from court just because if we didn't follow those procedures, it's no longer maintaining that integrity. Specifically, if we don't have a search warrant, if we're doing a criminal case, again, it just makes it inadmissible. Okay, so when we collect digital evidence, we're going to be using software or hardware tools. The software tools are just going to vary just depending on our needs. So what we're going to do is we're going to use a piece of software. It's going to remotely access the device that we're trying to investigate. We never want to install a new piece of software on there, just because if we do, it's going to change the information on that device. When we look at hardware tools, these are just going to be little devices that we can plug into our device that we're investigating. This is going to be when we actually have physical possession of the device. And so if we have a computer we're investigating, we can use these hardware tools to plug in directly into our computers. We also want to make sure when we're using hardware tools that the device we're looking at actually can receive power to it so we can turn it back on. And then we want to make sure that there is some sort of interface, either through a USB port or an SD card reader, so that way we can plug our devices into it. And then when we're collecting digital evidence, what we're actually collecting are artifacts. And so this is going to be the information stored on the computer. It could be files, it could be information logs. So all of these artifacts are going to be what makes up that digital evidence. So now that we understand the evidence, what types of data there are, the ways we can collect it, we're just going to look at how a computer typically operates. So I'm going to ask you for your input again. So the first aspect that we're going to look at is the CPU. This is essentially the brains of the computer. This is going to be telling the computer what processes it's going to do. It's going to be recording all the information. So who can give me an example of what type of information is passed through the CPU?
Everything.
Everything, yeah. Okay. So the operating system on our devices is going to control what's maintained, what's being created, what's being terminated in that CPU. It's going to be allocating all of the processes to given tasks. Anytime there's a piece of malware, either if it's code or an actual file, it's going to be showing in these processes. And is going to be able to be seen in the CPU and that process list. The next part of the computer we're going to look at is the RAM. So who can tell me a little bit about the RAM? What exactly is it? Yeah.
It's just temporary data storage that you can use for all package processes.
Yeah. Yep. So when we look at the temporary storage, this is going to be that information that is going to be lost when the device gets turned off, just because it is temporary storage. It's called non-persistent memory or volatile memory. The next aspect is going to be our disk and flash, and this is going to be our persistent storage. And so who can tell me how the disk or that persistent storage is different than that temporary storage? Yeah.
Temporary storage disappears when you shut the computer off, versus like your storage will just sit in the disk and disappear until you read it.
Yeah. Definitely good. Anybody else? Okay, sorry, it's all hand. Okay, so when we're looking at temporary and that permanent storage, we're going to be looking at the artifacts that reside in those spaces. So that's going to be the volatile and the non-volatile artifacts. And so the volatile is just going to be that temporary storage where it is basically erased whenever you do a power cycle. We want to make sure that we're capturing volatile memory for those artifacts when the computer is on. And so if an attack occurs, Whoever's getting attacked, make sure you leave your computer on so that way the forensics team can come in and then extract that information. If the computer does get turned off or that device gets turned off, all that information is just going to be erased. When we're capturing volatile artifacts, this is the fastest process that we have when capturing artifacts, just because the files, the information in RAM or that temporary storage is going to be a lot smaller than when we look at our disks. When we're looking at the disk or flash components that for system storage, we're really talking about non-volatile artifacts. Again, this is going to be the information stored on a actual device. And so when the device loses power and it gets turned back on, we can actually extract that information. So this might be a file that's living on your C drive or any other drive that you might have allocated to your computer. This can be captured when the system is actually still on or when it's offline, just again, because it's actually physically on your device. The way we capture these non-volatile artifacts just really depends on our investigation and the extent of that, and I'll cover some of those aspects here in a little bit. And then all the information that resides on our disk spaces are quite large, and so this is going to be a lot slower than collecting that volatile memory. And we've already captured all that. The only important thing here that we haven't covered is that when we're collecting volatile artifacts, we want to make sure that we're not triggering any antivirus on the computer, because if we remote into a system and it triggers that antivirus, any sort of malware that was on the RAM space is going to be lost. And then we basically lose all of our data for the investigation. So here are some examples of some of the software tools that can be used to capture volatile memory. These are going to create those hash functions automatically when you do the extractions. So that way, when you're comparing the data that you originally collected to the end of the investigation, you can see if there's been any modification. A lot of these tools also let you do the analysis portion, which we'll cover here in just a little bit. But anyway, multi-use, yeah.
So do you turn the antivirus off or do you have to leave it on?
Yeah, you'll want to turn the antivirus off, and there's sometimes ways to make it look like it's like just kind of skip over the antivirus. It just depends on the tool that you're actually using. So you just need to understand the type of data you're looking for, the software tools that you're using. Yeah, question. Any other questions? For the non-volatile artifacts, again, we're going to want to make sure that the device that we're using has power to it. We want to have physical and virtual access to that device, just because we can use software or hardware tools to collect this. There are two types of the non-volatile artifacts. There's a physical and there's a logical disk capture. Okay. So when we're looking at physical disk capture, we're doing an entire capture of what's on the disk, what's on that disk space. This is the most defendable and forensically sound, just because we're collecting all the data that is available. This includes possibly those deleted files, the remnants of those files in memory, just if they have not been replaced in the memory slots. This is the most time consuming, just because that output file is going to be really, really large. The next type of non-volatile artifact capture is this logical disk capture. This is going to be more of a targeted capture. So we're anything that we can see in our file explorer is that file tree. If we see a file that's located there, we can specifically target that. The downside to this is we're not going to be able to see any of the files that have been deleted. So we're not able to capture any of those in this logical disk capture. This is a lot quicker because the output files are going to be smaller because we're targeting specific things. And here are some examples of the hardware tools. These hardware tools use what's called a write blocker that just gives you read-only permissions. And so that way you're not accidentally creating any new information on the device that you're looking at. And it's just maintaining the integrity of the machine. So that's really important to note. So again, the hardware tools are going to have their way of maintaining integrity. Software tools are going to have their way of maintaining integrity. It just depends on which one you're using. And then we have our network captures. So this can be done with hardware, software tools. You can see a couple of examples in the top right corner. Excuse me, I'm a little bit backwards from you guys. So we're gonna be using the taps. So there's gonna be extra ports that you plug in, or you can have a monitoring port. So that way, you're not pushing any additional information onto the network. You can extract a full capture of all the information that's being transferred. And it also gives you information about the standard and non-standard protocols that may have been used. This is really important because if somebody is using a non-standard protocol, this could be an indication that you may have been hacked. And then as things are evolving on our network security protocols, it's making it a little bit more difficult to decrypt information. And so this is one of the downsides to network artifacts. Again, because as things are evolving, we're trying to catch up, but we're not maybe as fast as the computer is. Anytime we're collecting evidence, really important to remember those dynamics. We're in the real world, things change, things get moved around. So no matter what we do, no matter what we try to control, things are just constantly changing, they're constantly evolving. That's what makes our world really exciting, is that things are just constantly interacting, changing. Things are always the same. We'd be pretty bored. At least I would. I don't know about you guys. Okay. Any questions on anything so far? There are a lot of open source software tools that are available for us to be able to do the analysis portion. Again, a lot of the analysis tools are paired with the capturing tools. And so it just really depends on what you're using. This first one here is called the CySER workstation. This was actually created and written by the SANS Institute, so it's really good. It incorporates a lot of the tools, the software tools that are available and out there, so you're not having to look around for different ones. If you're wanting and you have a favorite, or maybe your organization has a specific one that you have to use, you can go ahead and look at other ones. These are just a very few select couple. There's also proprietary tools. Those are the ones that you actually have to purchase. They can be really cheap to really expensive. It really just depends. And then when you're looking at tools, just remember you get what you pay for. So if you use a free tool, well, it may have a lot of limitations on that. I have a link for volatility 3 here, just because that's the one that we're going to be looking at. We're going to be doing a memory forensics investigation. And so if you want to see more information or the documentation, that link will be available on my slides when those are released. Okay, so volatility 3 is what we're going to be using. It's written in Python, and it gives you a lot of memory forensics investigation aspects. And so this is going to let you look at Windows, Mac, and Linux operating systems. Unfortunately, those are the only ones that it allows you to look at. So if you have a Raspberry Pi, you're going to have to use a different tool. Anytime we do the investigation, we're collecting the evidence, and then we're taking that evidence to a different computer or a different device to do the analysis. And so this volatility 3 is going to be independent of the device that actually has the investigation ongoing. Since we're looking at memory, we're looking at the running state. So that's going to look at the executable files, those DLL files. And then for volatility 3, there's, I think, over 200 plugins that let you look at various different aspects of what's contained in memory. So if you're doing a network investigation, there's plugins for that. If you're looking at the process tree, there's plugins for that. So if you're curious about looking more at comparing those commands, you can go here. All the ones that we're going to be using, I have listed for you in the instructions, and so it should be pretty straightforward and easy. So again, there's some of the plugins that I have listed here. The other cool thing, since it's Python and you're using a command line, you can use the typing commands, and so we can actually search for strings. So if we're wanting to look for listening ports or let's open ports, we can use the quotations and listening. If we're wanting to look for a specific IP address, because we saw something pop up in that process tree, we can search for a specific IP address, and then it just makes the analysis a lot quicker. We can also dump a process, and so this is looking specifically at a process. So when we look at a tree, there's a lot of processes. Each one of them has a unique ID, and I'll show you that here in just a minute. We can look specifically at that process and then dump all that information to another paper for us to do further analysis on it. Okay, any questions so far? Okay. So let's go ahead and take a look at volatility 3. I know a few of you had some problems getting this installed on the Kali Linux. Who was able to get this installed? Okay, a good number of you. Good, cool. So for those of you who could not get installed, that's okay. You can do most of these on a Windows subsystem for Linux, most of the steps, or you can do it in your Mac terminal. The last two steps in the second part of the capture the flag is going to, let me show why that's. The last two steps I have noted, don't do that. Go find somebody on VirtualBox or a virtual machine, just because I don't want your computers getting infected by any sort of malicious anything. So please make sure you're adhering to the bolded section of the instructions. Okay, so volatility 3 is a command line, and so we'll open the terminal in your virtual machine. It's just up here. And I'll zoom in so you can actually see what's going on here. Okay. So I have already run these commands, and so you're going to see them auto-populate. I have, again, all the instructions in the, or all the commands listed in the instructions when those are available. But for right now, we'll just go through this. And so if I'm wanting to look for the process tree, I can load the file that I'm wanting to investigate, and then we'll look at a process tree here. I'm actually going to expand this a little bit so it's not too funky. And it's just going to take a couple of minutes to actually run because it's looking through, a pretty large file. I think this first memory file that we're going to be looking at is about 3 gigs. And so this is going to be like our task manager where we see the process list, when you go in there and see where everything's allocated. So this is going to give a unique identifier to each one. You're going to see the parent processes, and then you're going to be able to see any child process that was spawned from it. And so it just follows that tree structure. Okay, cool. So the header here is just going to give you the information on what each of these columns, if you can see it in columns, what each of those are related to. So you see this PID here. There's a number down in this section. That's just going to be your process ID. So we see here, we have the system. It has a process ID of 4. And then we see this next level here, it has a star. This is just going to be that first level child. It's going to have a process ID of 292. And then under PPID, that's going to be your parent process ID. And then you're going to see that this executable here was spawned from your parent process of 4, because there's a 4. It's going to give you the memory address for that process. It's going to give you a lot of information of when it was created, when it was actually run, the paths that it's associated with. So you can see a lot of information just from this process. If we're wanting to look for those, the network ports that are being listened to, we can go ahead and do that as well in this. So we'll do that. Okay. We'll use that one. So again, this is just going to take a couple of minutes to run. Just again, we're looking at a pretty large file. Because I'm doing a piping command, just looking specifically for the listening ports, it's going to show me anything that's actually open. So the rest of the information in this memory file that's not considered a listening port is not going to be shown in this output. If we want to see all of the ports, we can just omit the script listening and just run the net scan. Anytime we do the piping commands, it is going to get rid of those header identifications. So you saw before, it gave you the process ID numbers listed up here and then gave you the information. Here it's just going to give you the information, so you're going to need to know what's going on. Otherwise, you can run the network scan without the listening, and then we'll get the full information. Essentially, it's going to give you the address of memory, the network protocol that was used, the IP address for your local computer, the port number for your local computer. It's going to give you the IP address over here for the infiltrating computer. It's going to give you the port that the other computer was using, and then going to give you all the information on the executables for all those timestamps. There. So when we run the network scan without that pipe operator, we see all the header information there. Okay, pretty cool, huh? Okay, any questions on that? Okay, I'm sure there's going to be questions when you guys are doing the capture the flag. I'm here for you. Just raise your hand. I'll run over to you. All right. Okay, during the capture the flag, there's going to be additional tools that we're going to be using. There's lots more available, but these are the only 3 additional ones that we're going to use. So the first one is CyberChef. We can decode or encode strings. So when we're looking for any sort of malicious file or code that has been encoded by a malicious actor, we can go to this website and decode it. It's really cool. And I'll show you an example here in just a minute. We also have Virus Total, which is going to be able to scan files if we upload it. It's going to be looking at URLs, domain names, any sort of digital data that you can think of. If it has been flagged, Virus Total will be able to give you some sort of report on it, including hash functions. And then the last tool that we're going to look at is Goldfinch PST Viewer. This is just going to give you information on emails that were sent and received. You'll be able to see calendars, all that cool information. So we've already covered what CyberChef is. So again, it's a web application that lets you encrypt or decrypt strings. It uses what's called recipes. So this is CyberChef. And you can Google it, it's really easy. So it gives you a list of methods here that can be used to encode or decode a string. We have this recipe block here. And so you just basically pop your methods over here and then you're good to go. So I'm going to paste that input that I had on my slides here. And normally when you load CyberChef, it's going to have a check mark and auto bake. I have that turned off right now just because I want to show you the step-by-step recipe building. So as you're working with these strings, you see them in your process list or any of the string files that you create. You're going to be able to distinguish what kind of encoding methods were used. That's not my aspect of teaching you which one is which, but in this case, I encoded the string from base 64. And so I'm just going to pop that over to my recipe. Hasn't done anything yet just because I have not hit bake. And so once I hit bake, it's going to give me some sort of output in the pointer. Can you guys see that okay? Give it a little bit. Better. So it's going to give us some sort of weird number, percentage sign, letters. This is just another encryption technique. So here I use text in order to do that. So I can go over to the methods that are available. I'll just drag over from hex. I'm just going to leave it on auto so that way it can just choose what it's doing. We're going to hit bake again, and well, now we have a decrypted string. So pretty neat, pretty good tool. Any questions on that? Where are we at? Oh, we're doing good on time. Cool.
So with the auto bake, will it just automatically, it'll go through and check different things slowly?
So when you have auto bake on, let me get back to here. So if I don't have any recipes there and I click auto bake, that. Let me do that. Cool. Bake. Okay. So if I have auto bake on, as soon as I drag a method over, it's going to start decrypting it. So I just wanted to turn it off so that way I could build it up. Yeah. Good question.
Does it just have like standard encryption techniques? Like, does it have like a classic CySER shift or something?
So you can search any here. There's a lot of different methods. So we have encryption and coding, and so it gives you a full list of all sorts of encryption techniques. So if you want to send your mom or dad some sort of cryptic message, you can even just go here, write your own message and encode it, send it to them, give them a recipe, and hey, you just sent them a really cool string. Send them a message. Good questions. Any others? The next tool that we're going to look at is Virus Total. So again, this is a web application, massive database that reports any sort of malicious files or malware signatures. So we can look at uploading a file or just looking for a specific URL. It's gonna give us any information about if it has been flagged, how many sources have actually flagged it. The IP addresses associated with it, or that's what we're looking for. It's also gonna give you those hash functions. Information about what kind of malicious file it is. Is it a Trojan? Is it a phishing attempt? So we can take a look at that. Has anybody used this before? Okay, cool. So I'm not just giving you information you already know. That's exciting. Toolbar here. So I had that website that I just grabbed from my PowerPoint slides. I did a little bit of Googling and found a list of malicious websites. So we'll just take a look at it here. So we'll go up to the search bar here, we'll copy it in, hit enter, and then it's going to scan through its database, and then it's going to give us a report. And so we see 5 out of 94 sources have actually flagged this as a phishing, malware, malicious type of URL. We can go over to this. Well, first, if we scroll down, we can see all the organizations and scanning sources that have actually looked at this. And they'll report if it's been clean, if it's malicious, or if they haven't actually looked at it yet. You can click into the details tab. And so this will give you more information. Since this is a website, it's going to give you all the certificate information. It's going to give you a fingerprint number here. So it's kind of like that hash function. In the capture the flag, you're going to upload a actual malicious file to this, and then you're going to be able to see all the information that is available here. Okay. Any questions on this? Cool. Pretty straightforward. Okay, perfect. And then the last tool that we're going to be looking at is called Goldfinch PST Viewer. So again, this is going to let you see any calendar, email information. PST is a specific email archive specific to Outlook. OST is for other types of emails. So you can see all the message stamps. You can see the actual messages. You can see if there's any attachments inside of the email. Anybody use this before? Cool. So let me log back into Kali Linux. Again, I don't want to infect my computer. That would be a bad day. So I already have run the capture the flag because I just want to make sure everything was worked before I give it to you guys, because that would be really mean of me if I didn't. So these are already my computer, so I'm just going to look really quick for them. So what I'm going to be looking for are PST files. And so I'm just going to go to the search function in the folder, and I know exactly what I'm looking for. So I'm just going to grab it and pop that in here. And so when you load it, anything that is a good file is going to look like this. You guys see it okay? No. I'll zoom in a little bit more. Okay. Anything that's a good file is going to look like this. If it's a bad file, it's going to have an exclamation next to it. Since this one is a good file, I can click this drop down or expand arrow. It's going to let me see this inbox here. And so we can click that, and then we can see the actual emails, all the timestamps, who it was from, who it was to. If we click on an email, we can actually see the message that was inside the email. So that's pretty cool. That's pretty useful. Any of these that have attachments, it's going to let us know there is an attachment. And so you can see the attachment. Again, only do this in your virtual machines. If you download the attachment, which you can do in PST Viewer, so I can click save, it will download it. Please only do this in your virtual machine because, again, it's malicious and we don't want to do that. Okay. After you download the attachment, you can go over to VirusTotal. And then you can upload that file to VirusTotal. One second here. Okay. So we have that file there, and then we can pop it over into VirusTotal. We can pop that into here, and then it's just going to scan the file and then just give us a report like it did with that website. I'm not going to zoom in very well because that's part of your guys' capture the flag thing to give me more detail on that. So any question on either of those schools? Okay. Sweet. So why we're doing analysis, it's just really important to remember that, we're never going to be 100% certain of anything that we look at. We can only make hypotheses about the data that we have collected. Are those hypotheses through our analysis supported or refuted by what we've actually collected? Is this actually going to support that legal investigation? And then we always want to make sure that any type of analysis we're doing is repeatable and reproducible. If we do an analysis and our buddy does something else and we get conflicting results, can't really use that in court because now you have conflicting data. Okay, any questions?
You will go back a couple slides.
Yeah.
We're almost never certain this second term. Okay. So my question is, you're collecting digital forensic data
Mhm.
on maybe a malware, Azure, whatever. If we get this data and want to use it legally, how do you find that accurate? They're in virtual space somewhere.
So you can, it's a good question, thank you. So you can track down those IP addresses. And those IP addresses can oftentimes see the MAC address of a device, and then you can actually look for the geo-referencing location of where the IP address initiated from the servers. Yeah, good question. Any other questions? Whenever you're geolocating anything, I mean, there's always, this is where geography comes into play. So there's always going to be uncertainty about the actual radius or the area, so we can never exactly pinpoint somebody. We can only do it in like a specific range of their location. And so even like if you're looking for a phone and you're trying to trace it, you might be able to get a 10-foot estimation of where it's actually at. And then when you're indoors, it kind of goes down from there. Oh. Anything else? If you are interested in this, you can learn more about the incident response. The digital forensics is just one small aspect of this incident response. Again, just to conserve time, I'm not going to go through this, but it is available on my slides for you to look at. Excuse me if I'm scrolling too fast. Again, there are careers that you can do if you're interested in. Just note that if you decide to do digital forensics or any sort of cybersecurity thing, there's always going to be certifications that you're going to need. So there's some of them less secure or a lot more that are available. A lot of times, if you get hired on by somebody, they are going to pay for you to get these certifications. But it's always good to know that they are available. Okay, so now we're at the capture the flag. James, are those slides